Alright folks, in this video we're gonna review Lewis structures for covalent compounds. Here these are the guidelines for us to do this work. First one is we need to write the correct skeletal structure for the molecules. And two things I need you to remember. The first one is the central atom should be the atom with less electron negativity. Okay, and if you remember electron negativity, if we are talking about the elements in the same period, usually overall the electron negativity will increase when you go from left side to right side. Okay, if you are talking about the elements in the same group, then overall electron negativity will decrease when you go from top to bottom. Okay, I need you to remember the trends for electron negativity. And then the second thing is the hydrogen is always terminal atoms. Okay, we're going to see example. The second step is we need to calculate the total number of the valence electrons for the Lewis structures. Okay, and if you have a polyatomic ion, then you have two possibilities. If the polyatomic ion is negatively charged, then you add the negative charge when you count the total number of the valence electrons. If the polyatomic ion is positively charged, then you need to subtract the number of the charge from the total number of the valence electrons. Okay. Step 3. Then after we calculate the total number of the valence electrons, we need to distribute the electrons among the atoms. Okay. Then in this part, we need to follow octet or duet rule. Octet rule means that the atom usually will get 8 electrons. Duet rule means the atom will get 2 electrons. Remember, the duet rule is only for hydrogen or helium. Okay, these two elements, because they are so small, they only have space for maximum 2 electrons. Okay, so the other elements, most likely they are going to follow octet rule. Step 4. If any atoms lack an octet, then probably you need to use double bond or even triple bonds to make sure that all of the atoms have satisfied the octet rule. Okay, and here one thing that we need to remember is that fluorine will never form double bonds. Okay, because fluorine has such a high electron negativity, it will never share more than 2 electrons with other elements. Okay, now let's just use the example to demonstrate how we follow those guidelines. Let's take a look at the first example. Let's see CH4. Okay, very simple molecule. You have carbon and hydrogen. And if you are looking at the rule number 1, hydrogen is always a terminal atom. That means in this molecule, carbon should be the central atom. Okay. Now, step 1, write the correct skeletal structure for the molecule. Central atom, carbon. 4 hydrogens around the central carbon atom. Then we just draw the 4 hydrogens around it. And then the next one is we draw single bond. Okay, between the carbon-hydrogen pairs. Okay, this is step 1, a skeletal structure for the molecule. Step 2, calculate the total number of the valence electrons for the Lewis structures. Now, carbon, we know that because it's group 14. Okay, so 14 minus 10, that means it has 4 valence electrons. 4 hydrogens. Each hydrogen, we know that it has only 1 electron, so 4 times 1 electron, so total is 4. Okay, sorry about the equal sign here, it should be equal sign. Okay, 4 electrons from 4 hydrogens, then total valence electrons would be 8. Now we need to step 3, we need to distribute those electrons among the atoms and make sure that either those atoms satisfy octet rule or duet rule. Now, when you look at this molecule, skeletal structure, you have 4 hydrogens, 1 central carbon atom. Now, when you count the electrons we've already used, remember, each single bond represents 2 electrons. So 1, 2, 3, 4. 4 single bonds. That means 8 electrons. That tells us we've already used all of the 8 electrons. So we don't have any extra electrons left. So we need to just double check whether everybody's happy or not. Hydrogen, because it shares 2 electrons with carbon, okay, so hydrogen has 2 electrons. So it satisfies the duet rule. All 4 hydrogens have 2 electrons, so all 4 of them are happy. For carbon, because you have 4 CH single bonds around the central carbon, so total number of the electrons around the carbon is 8. So carbon satisfies octet rule. All right, so now everybody is happy, and we don't have to go through step 4 for this molecule because there's no need to form double bond or triple bond to make sure carbon has 8 electrons and hydrogen has 2 electrons. So this is example 1, CH4. Now let's take a look at the second example. Okay, NF3. Well, step 1, skeletal structure. Now, when you compare the electron negativity of nitrogen and fluorine, apparently nitrogen would have less electron negativity than fluorine, okay? Because fluorine has the highest electron negativity in the whole periodic table. So, step 1, nitrogen central atom, fluorine terminal atom, okay? And skeletal structure is like this. We draw single bonds no matter what kind of elements you have, because if you are talking about the molecule, those atoms are interact with each other. At least they should form a single bond, right? All right, now this is a skeletal structure. Let's go to step 2, total number of the valence electrons. Nitrogen, 5. Okay, group 15, so 15 minus 10, that is 5 valence electrons. Fluorine, you have 3 fluorine. Each fluorine has 7 electrons because 17 minus 10, that is 7 valence electrons. And because you have 3, so 3 times 7 electrons each, that is 21 electrons. So total we have 26 electrons. Now, step 3, we need to distribute the electrons among the atoms. And remember, octet and duet rule. We don't have hydrogen or helium in this molecule, so we are just going to follow octet rule. 26. Now let's just make sure fluorine is happy first, because when you have a fluorine with a high electron negativity, fluorine likes electrons. So let's just right now, fluorine has 2 electrons. Now let's give it 6 more electrons to make sure that this fluorine is happy, okay? And again, same thing here. We need to give this fluorine 6 electrons to make sure this fluorine is happy. And same thing here for this fluorine, 6 electrons for it, okay? Now, if you count the total number of the electrons we've already used, you have 8 here, okay, you have 8 here, and you have 8 here, you have 8 here, so total we used 24. All right, 24 electrons we've already used. We still have 2 electrons left. And when you look at this structure, fluorines are happy enough because each one of them has 8 electrons. But nitrogen is not happy at all because 3 single bonds, 6 electrons. So nitrogen needs electrons. And we have 2 electrons left. So how about we just put these 2 electrons on nitrogen? Okay. So now if you count the electrons for nitrogen, 8 for nitrogen. So nitrogen is happy. 3 fluorines are happy. Everybody is good. All right. So this is the Lewis structure of this NF3. And remember the rule number 4, okay, step 4 says fluorine will never form double bond. So here is that you will never share the lone pairs on fluorine atom to form double bonds, okay, even if nitrogen needs electrons, okay. So this is the second example. Now let's take a look at the third example. NO3 minus nitrate. This is a polyatomic ion, okay, and it's negatively charged. Now, step 1, skeletal structure. Nitrogen, oxygen. Nitrogen has less electron negativity, okay, so nitrogen, oxygen, oxygen here, and single bonds for each pair. All right, now let's count the total valence electrons. Nitrogen, 5. 3 oxygens. Each oxygen has 6 electrons. Okay, group 16. 16 minus 10, that is 6 electrons each. So 3 times 6 electrons, that is 18. All right. Now, like I said in step 2, if you have a negatively charged polyatomic ion, then you need to add the negative charge when you count the total valence electrons. Since it has 1 negative charge, so you need to add 1 electrons when you count the total valence electrons. Okay, so it's 24. All right, 24 electrons. Now let's distribute the total 24 electrons in these molecules. Again, you make sure oxygen is happy first, because oxygen right now it has only 2 electrons, so you need to add 6 electrons around the oxygen, okay, each one of them, so it satisfies the octet rule. And this is oxygen. Now, if you count the number of the electrons we've already used, you have 8 here, you have 8 here, and you have 8 here. So total 24 electrons. That means we've already used all of the 24 electrons. But nitrogen is not happy at all, because nitrogen, so far, it has only 6 electrons. What should we do in this case? Okay. Remember, if that atom lack an octet, then and you don't have any extra electrons to add to the central atom as a lone pair like we did for example number 2, then you need to form double bond. Okay, so let me write it here. So let's just say that this oxygen will share 1 lone pair with the nitrogen. So what we will see is like this. Okay, so you have still 6 electrons for the other 2 oxygens. But you would have a double bond between this nitrogen and oxygen. And because nitrogen share 1 lone pair, so it has 2 lone pairs left. Okay, so this is Lewis structure of the NO3 minus. Okay, we use the bracket and the negative sign outside the Lewis structure to represent that this is a negative charged polyatomic ion. All right, and let me just remind you, if you remember the resonance structures, because these 3 oxygens they have equal chance to share their lone pair with nitrogen to form double bond. So this double bond can migrate among those 3 pairs. That means that okay, let me use a red color to highlight. So that means this double bond can be here in this area or in this area. Okay, so this is resonance structures. I hope this video can demonstrate how we follow those guidelines to draw the Lewis structures, and there are many examples that you can try. And if you need any extra practice, please let me know. I can help you with that. All right.